Hello students, today we are going to study metals and non-metals. To start with, we all know that everything which is present around us is known as matter. Okay, and if we talk about the definition of matter, we can say that anything which occupies space and has got mass is known as matter. Okay, so let's write and just see what it is. Anything which is present around us is known as matter. And when we talk about definition, anything which occupies space and has got mass is called matter. Now when we talk about examples of matter, we all know everything, like the chalks in my hand, this blackboard, this duster, everything is matter. Okay. Now this matter can be present in different forms. Now what are the different forms in which this matter can be present? Let's have a look. It can be in the form of elements, or it can be in the form of the compounds, or even it can be in the form of the mixtures. Okay, so now what we are saying, that matter can be present in the form of the elements, compounds and mixtures. Now to begin with, what do you mean by elements? What actually elements are? So we can say element is the purest form of the substance. What it is? It is purest form of any substance. Okay, and secondly, it is made up of same kind of atoms. Okay, same kind of atoms are present. Now to explain further, what does it mean by when I am saying elements are purest form of any substance and it is made up of same kind of atoms? Means what? If you take such a big piece of element and suppose the structure of element is like this. Now suppose the atoms are like this. Okay. Now if you break this, if this element is this big, if you break down into smaller pieces, then also there will be no change in the characteristic feature of the element atoms of that big piece or the smallest piece. And this is also what? Purest form of any substance. That means only one kind of atoms are present in any element. Okay. Now what can be the examples of element? Actually in all there are 118 elements. There are in total 118 elements, out of which 92 elements are natural. In total there are 118 elements, out of which 92 elements are natural. Now out of this 92 natural elements, 70 are metals and approx 22 are non-metals. Okay. Now how do we know that this particular element is metals or non-metal? Okay. We can judge this on the basis of the characteristic features which we are going to study today. Before starting that characteristic feature, we will again just have a look on the classification which was given by the scientist named Lavoisier. So what was his classification? He said elements can be divided into three categories like metals, non-metals and one more, that is metalloids. So now elements can be divided into three categories: metals, non-metals and metalloids. Now we are going to study totally about the physical properties of the metals. Just have a look about the physical property of the metals. To begin with, first we will talk about the physical state. Now this is the first property we are talking about, and here I will be writing about the metals and definitely here about the non-metals. Now first of all, what is the meaning of a physical state? Physical state means, when I am talking about an element, that means an element is in which condition, which state. That means whether it is in a solid state, it is in a liquid state or it is in a gaseous form. Okay, so this is the meaning of the physical state. Now when I am talking about the metals physical state, usually all the metals are in the solid form. Now I am using the word usually. Okay, now whenever we are reading physical properties of metals and non-metals, just keep one thing in mind, that always will be having some exceptions. Okay, so physical state of metals generally all are in solid form. Okay, now the examples can be copper, magnesium, iron, aluminium, silver and many more. Now I am talking about, now this is the solid form, natural, at room temperature. Now when I talk about the exception, that means which are the elements which are not present in the solid form. So if we talk about that exception, mercury and gallium. Mercury, gallium are the metals which are present in the liquid form even in the room, even at the room temperature. Okay, now when we talk about non-metals, in non-metals actually we can say that non-metals are usually present in the form of the solid or gaseous form. Now when we talk about solid, what can be the examples? It can be sulfur, it can be phosphorus, it can be iodine. Okay, now what is the gaseous form? It can be hydrogen, it can be oxygen, it can be nitrogen. Okay, now what is the exception over here? The exception can be bromine. Now this bromine is present in the liquid form. This bromine is present in which form? It is present in a liquid form. Okay, so this was our first property. At present we are discussing about the physical state. When we talk about the physical state of metals, all the metals generally are solid at room temperature. Take the example of iron, copper, magnesium, aluminium. Okay, now when we talk about the exception, that means which are the metals which are not in a solid state at room temperature. So we can say mercury and gallium, even cesium. These are the metals which are present in the liquid state. Okay, when we talk about non-metals, these are present in usually solid and gaseous state. When we talk about the example of the solid, the example can be sulfur. I have written symbols over here. Sulfur and phosphorus. When we talk about gaseous state, it can be hydrogen, it can be oxygen, it can be nitrogen. When we talk about exception, so bromine is present in the liquid state. Now we are going to talk about the second property of the, we are going to discuss now second property. Now when we talk about the second property, the second thing comes in my mind is a shine. We all know that metals have a particular shine. You take the example of the gold, you take the example of the silver, you take the example of many metals, and you can find that these metals shine in a different way. Okay, so this shine, this metallic shine is known as luster. So second point is luster. Now we have discussed physical state. Now we are going to talk about the second property. When I think about the second property, the first thing which comes in my mind is luster. Okay, so it is luster. What is the meaning of luster? Luster means shine, a metallic shine which is present on almost all the metals, but you know, it is sometimes more for some metals and sometimes less for some metals. Say for example, silver and gold is having a fabulous shine, and that is the reason that silver and gold are used for making jewelries, decorative pieces and so forth. Okay, now when we talk about this, I am talking about metals, and here I'll be writing about non-metals. When we talk about luster in metals, sodium and potassium has less luster. But do you know why it is having less luster? Because a layer of oxide get deposited on these kind of metals. But if it is cut by the knife and a fresh part is removed, again we will see that even these metals have luster. Now non-metals are generally, they are non-lustrous. That means they do not have shine. It do not have shine. Again, exception here is graphite. I am talking about exception. We can see that little shine can be seen on the graphite. Okay, so now third is malleability. First of all, what is the meaning of malleability? This is a very specific and special property of metals, due to which when metals are beaten, it gets converted into a long thin sheets. Take the example of a coin. If you take you have seen the bottles of the Coca-Colas or Thumbs Up, remove that upper cover or the coin of that and try to hammer it. You will find that automatically it get converted into thinner sheet. Okay, what is happening? It is nothing but the property of the metal of being beaten and getting converted into sheets. Again, if you take the example of the Indian sweets like Rasgulla or Kaju Katli, you might have seen certain silver color layer is there on these kind of sweets. What is this layer? This layer is nothing but a small thin foil or cover or sheet of silver. Again, when we talk about sheets, take the example of the foil, aluminum foil, which is used for the packaging of food, even for the picnics, trips, or even for the normal also we pack our food in aluminum foil. Okay, so what is malleability? It is the property of metals to be converted into thin sheets when beaten. Okay, so what is malleability? We all have understood now. Here we can take the example of aluminum. Just now I told you we have discussed about the aluminum foil. Then again silver foil also. Okay. Now when we talk about this property in non-metals are generally non-malleable. Okay, that means we cannot convert a non-metal into a sheet. Just take the example of even wood. If I keep on hammering it, it is going to break into smaller pieces, but it won't be converted into a sheet. Okay, if I hammer this chalk, okay, what will happen? It will just get broken into smaller and smaller pieces, but again it won't be converted into a sheet. So what can I write in non-metals? These are non-malleable. Okay, and again the examples can be what? You can take any example, maybe plastic, maybe wood, maybe sulfur, okay, maybe iodine, maybe bromine. It can't be converted into sheets. Now to talk about next property, again now we will talk about ductility. Now what is the meaning of ductility? Ductility is a property where if the metals are beaten, or like we can say, it can be drawn into wires. Now when we talk about wires, you might have seen long wires which is being used in the electric gadgets, and even if you have seen embroidery fabric, that means the fabric on which embroidery is being done. You will be surprised to know that from 1 gram of gold, a 2 kilometer long thread can be made. Such a ductile gold is. That means ductile is a capability of a metal by which it can be drawn into wires. That means to make the wires from the metals. Okay. So now what we are talking about? Now we are talking about fourth property, which is ductility. Now first of all I will write the definition of the ductility. What is ductility? Ductility means what? The capacity of the metals to be drawn into wires. Okay. Now it is the capacity of metals to be drawn into wires. So when we talk about the examples, just now we have discussed gold wires, and the very big example is what? The wires of the electric wires, which are generally everybody has seen, which are used in our houses. Okay, so it can be made by copper. Even aluminum wires are used. Okay, so when we talk, this was about what? Metals. Now when we talk about non-metals, I have written the metal property here only. Now when we talk about non-metals, these are like metals do not have ductile property. That means these are non-ductile. That means if I want to make non-metals, I want to convert them into wires, I won't be able to do this because non-metals do not have this property. Now to discuss with next is good conductors of heat. Now what is the meaning of good conductors? We are reading this thing, or we know this thing from, like we have read this in 6th standard also, 7th standard also, that good conductors are what? What is the meaning of good conductors? Like it is the capacity to carry heat. Okay, that means heat can move from one part to the another part. So metals are very good conductors, and that is the reason that when we go and see in the kitchen, we will find our pens, our pressure cooker are usually made up of what, or we can say almost or every time it is made up of what, metals. But just pay attention, always these utensils will be made up of metals, but when we talk about the handles, handles are never made up of metals, always it will be having a covering of non-metals. Say for example of plastic, sometimes maybe of the wood. Why it is made up of non-metals? Because non-metals are bad conductors of heat. Okay. So what we are discussing? We are discussing good conductors of heat. All the metals are almost good conductors of heat. Now what examples can I write over here? I can write copper, I can write even silver. Okay, now even I can write aluminum. All these are good conductors of electricity or heat. Now when we talk about non-metals, all these are what? Bad conductors of heat. So next property is conductors of electricity. Again, I will be writing metals over here and non-metals over here. Now, first of all, what is the meaning of conductors of electricity? Now, we all know that we use electric wires at home for various gadgets, various electric gadgets, say fridge, TV, anything, whatever camera or anything you talk about, we always use certain electric wires. Now, how can we use electric wires? Why we are using electric wires? Because all metals are good conductors of electricity. Yeah, one thing is very true that few metals are very good conductors of electricity and in few it moves little bit slower. So when we talk about the best conductor of electricity, it is silver. Okay, and metals are what? All metals are very good conductors. Okay, so when we talk about silver, it is the best conductor and after this is copper. But as we all know, silver is very costly and we can't afford this silver to use in the electric wires at our home. Okay, and that is the reason in place of silver we usually go for aluminium. Okay, so we use copper wires and aluminum wires in electric cables. Okay. So just now what we have discussed, we are talking about conductors of electricity. All metals are very good conductors of electricity. Again, I am bringing this in your notice that metals are good conductors of electricity, but all metals do not conduct electricity at the same rate. Few are very good conductors, few are a little bit slower. In this, silver is the best conductor, then copper, but as silver is very costly, we avoid using this and we use copper and aluminum wires. So what I can write, or what should I write over here? I will write metals are good conductors of electricity. Okay. Now when we talk about non-metals, what should I write? I will write that these are bad conductors. Okay, non-metals do not conduct electricity. But as we have discussed, for everything we have got one or the other exception. In the same way, in non-metals also we have got exception, graphite. Graphite is very good conductor. Okay, it is very good conductor of electricity and that is the reason graphite is used in making electrodes. Okay, so when we talk about conductors of electricity, metals are good conductors, non-metals are bad conductors, but exception is graphite. Okay, now I will take next property of metals and non-metals, which is sonorous. Now First of all, what is the meaning of sonorous? You know, every metal has a specific sound, a ringing sound. See, when you go to school, you might have seen the bells made up of metals. Have you ever seen a bell made up of wood, only wood, totally wood, or a bell made up of a plastic? No. Why? Because plastic or the wood do not have that capacity of ringing. So what is sonorous? Sonorous is a capacity of metals to produce a ringing sound. Okay, so now what should I write in metals? All metals have this sonorous property, are sonorous. Or sonorous property, and this they do not produce a ringing sound. Okay, so this do not produce a ringing sound, and that is the reason all over wherever we see a bell, it will be always made up of metals and not of the non-metals. Now we will talk about the next property, which is melting and boiling points. Okay. Now all the metals have very high melting and boiling points, and you know, knowingly or unknowingly, this thing is there in your mind. You all know this, because just take the example of the iron. Can you melt iron? You all have utensils at your home which are made up of metals. When you keep these metals on the gas, do these utensils get melted? No, it can't. Okay, that is the reason we are using these utensils at home and various places. We are using this. Why? Because metals have which kind of point? It is having very high melting and boiling point. High melting point as well as boiling point. Okay. Now when we talk about non-metals, they do not have such high melting and boiling point. It is having very low melting point and boiling points. Say, take the example of the plastic. Okay, so plastic is what? It is a non-metal and it is having a low melting point and boiling points. Okay. Now when we talk about the next property, we will discuss about the density. First of all, to clear up what is the meaning of density. Density is what? Density is mass per unit volume. It is mass per unit volume. Okay, or in the simpler way, if I talk about, then the atoms of metals are very closely packed, These are very closely packed, and so it becomes more denser. Okay, it becomes more what? Denser. So what is there? We are discussing about the density. What is the meaning of density? Density can be defined as mass per unit volume. That means, in a simple language, the atoms of the metals are very closely packed, very tightly packed. Okay. So we can write in metals that density is very high. But non-metals have very low density. But again, remember about the exception when we talk about non-metals. Carbon is a non-metal, which is a non-metal, but again it is having a very high density, and even melting and boiling points of the carbon is very high. So I can write here also exception and here also exception. I'll use this chalks to make it very clear. Exception graphite or even diamond. Okay, that means both are the forms of the carbon. Now to discuss the next point, I will talk about hardness. I am writing about metals here only, and here I am writing about non-metals. Okay. Now when I am saying that it is having very high density, that means the atoms are very closely packed, very tightly packed, the melting points are high, the boiling points are high, and so when we say the hardness, the stiffness, metals are very, very hard. Just imagine if I ask you to cut iron with a knife, can you? No, you can't. But again, what is the exception? We have discussed that everything has got exceptions over here. So when we talk about what? Let's say for example sodium and potassium, these are the softest metal which can be even cut with the help of a knife. Okay. So first of all I will write hardness. Which metals are very, very hard? Say copper, hard metals. Okay, metals are very hard. And which metals are hard? Copper, iron, magnesium, all these are hard metals. But exception is what? Sodium and potassium are the very, very soft metals and can be cut even with the help of the knife. Now when we talk about non-metals, all the non-metals are very, very soft and brittle. Now what is the meaning of brittle? That means if you try to hammer it, you try to put little force, you apply force, it will get broken into smaller pieces. But again, exception, is diamond, which we all know is the hardest substance which we have ever known. Okay, so we have discussed the property hardness. All metals are very hard like copper, iron, magnesium. Again we have got some exceptions also like sodium and potassium are the metals which can be cut into pieces with the help of the knife. When we talk about non-metals, non-metals are very soft and brittle, that means it can be cut into smaller pieces, and it actually not cut into smaller pieces, just get broken into smaller pieces even on applying a little amount of force. But again the exception is what? Diamond. It is the hardest substance ever known for the human beings. So what are the points which we have discussed? We have discussed many points, like whatever we are discussing now, all these are physical properties of metals and non-metals. But we cannot distinguish metals and non-metals even on the basis of the physical properties. Why? Because we are seeing that for everything we have got one or the other exception. If we say कि whatever substance is very hard is metal, so no, again we have got exception. Okay, if we say that whatever substance is soft is non-metal, so again we have got an exception, diamond is the softest one. So on the basis of the physical properties we cannot divide the categories, we cannot divide a substance into metals and non-metals. For that we need to read further. But to go to the, before explaining the chemical properties, we will discuss few things which were left behind. Like if you all remember, we have discussed that elements can be divided into three: metals, non-metals and metalloids. Okay, so we have discussed metals, we have discussed non-metals, now metalloids are left. Now what is the meaning of metalloids? Metalloids are something which is having properties of both metals and non-metals. Okay, so what we are talking about? We are talking about metalloids Okay, how to define metalloids? Metalloids are something which shows the properties, which shows the property of metals as well as non-metals. Okay, now what can be the examples of this? Examples: arsenic, boron, silicon, germanium. Okay, so what is the meaning of metalloids? All those substances which shows the properties of metals as well as non-metals. Okay, now what can be the examples? Arsenic, boron, silicon, germanium. Okay, now few more things we have discussed before discussing matter. Like I said that matter can exist in different forms, say elements, compounds and mixtures. So we have discussed everything about elements, but now what about compounds and what about mixtures? So compounds are, how compounds are formed? When elements combine in a fixed proportion. When elements combine in a fixed proportion, compounds are formed. Okay, and when elements or compounds they combine in indefinite proportion, then mixtures are formed. Thank you.